Hi, welcome to our CompTIA Network Plus course. In this lesson, we're going to talk about switching technologies, and here we will discuss what VLAN is, or Virtual Local Area Network. We have interface configuration, what is spanning tree, and MTU. So switches are the backbone of modern networks operating at layer 2 of the OSI model. They intelligently forward traffic between devices within the same network segment and improving efficiency and security. Modern switches offer advanced features like VLANs. You have LACP, link aggregation. You also have QoS, or quality of service. And this feature allows for more granular control over network traffic and resource allocation. Now, proper switch configuration is very important for network performance, security, and scalability. Misconfigurations can lead to network loops, broadcast storms, and security vulnerabilities. I remember maybe that was 2016 or 2015 when we were asked to support a specific client because they have a huge broadcast storm in their own in their two data centers. So basically, it brought down the whole network because of misconfigurations on the switching environment of the client. So what happened is that all of their services hosted in their data centers are not accessible. So no payments, no transactions are coming through because of not following the best practices in the switching environment. So going back to the topic, let's talk about what VLAN is, right? So VLANs are logical divisions of a physical network, allowing multiple virtual networks to exist on a single physical infrastructure. VLAN enhance network security, improve performance, and simplify network management by logically grouping devices regardless of their physical location. Now, network segmentation through VLANs reduces broadcast domains, improves security through isolation, and allows for more flexible network designs. Now, VLANs are typically configured on switches and can span multiple switches using trunking protocols like 802.1q. So how do we configure a VLAN? From the old days, the old Cisco switches, we should go to the VLAN database first, like shown here, to be able to configure the VLAN. So once you go to the terminal, you go to configuration mode, right? Then type VLAN database. After that, you're going to go through this prompt. Then you can just put the VLAN ID. So that's VLAN, then 200. You can also put a name of that VLAN, right, on another line, like here. Then you can just exit, right? When you exit, then you can do a show VLAN, or maybe end, right? Then show VLAN. Then you'll see that the new VLAN has been applied. Okay. Another concept is SVI, or Switch Virtual Interface. So an SVI is a virtual interface within a switch that provides layer 3 processing for a VLAN. It acts as the gateway for inter-VLAN routing when layer 3 switching is enabled. SVIs allow switches to perform routing between VLANs without the need for an external router, improving network efficiency and reducing latency. So to configure an SVI, just create a VLAN interface using the interface VLAN and VLAN ID command. Then you can assign an IP address to enable layer 3 functionality. So in this illustration, as you will see, this is what you call as the VLAN interface, or the SVI, the switch virtual interface. So all of the hosts that is associated to VLAN 10 will use this IP address as its gateway. Okay. So if you have other VLANs and other SVIs, you can directly communicate to the other VLANs because the gateways are sitting on the same switch. You don't have to go to the router to be able to communicate, okay? Interface configuration basics. Here you can configure ports in access mode for end device connections. You need to use the switch port mode access command on Cisco devices. In switch port access VLAN, then you put the VLAN ID command. Here, this is a switch. This is a switch. If you have a port here connected to a laptop and machine, this will be configured as an access port or in access mode, which means only one VLAN will be, or data VLAN will be allowed. Okay. Now for trunk mode, you can set up trunks for switch to switch connections carrying multiple VLANs. So you can use the switch port mode trunk command and specify the allowed VLANs if needed. There's another concept called port security. It is used to limit the, well, there's a lot of functionality, right? For port security. One of them is to limit the number of MAC addresses per port, right? So why do we have to do that? So let's say this is a port. Let's say all of these ports, you put port security, limit the MAC address to just 2. Because sometimes you can connect a machine, a laptop, and an IP phone, right? So this will receive 2 MAC addresses, right? Now, if somebody brings a hub switch, right? So this means if this hub switch has, let's say, 12 ports, then you can connect, we should be able to connect 10 devices, 10 to 12 devices, right? But only 2 MAC addresses will be allowed. Okay, so we're actually putting more control on our switching environment. And, connecting a hub switch is very problematic because each, this is actually a very noisy device, right? Because it doesn't have the intelligence of a switch. So if there's a broadcast, then it's just going to forward it to all of the ports, right? If somebody wants to communicate to the other device, then it has to broadcast it to the other device every time a traffic is being sent. So it's really not good. It's bad. Another concept is native VLAN configuration. It is the VLAN assigned to untagged frames on a trunk port. By default, it usually is VLAN 1. You need to use the switch port trunk native VLAN, let's say here 88, to set a different native VLAN, because as a best practice, you have to change the native VLAN from the default VLAN 1 to enhanced security. You need to ensure that native VLAN matches on both sides of the trunk link. Another one is voice VLAN configuration. So voice VLAN separate voice traffic from data traffic, ensuring quality of service for VoIP communications. Here you need to enable voice VLAN on an interface using the switch port voice VLAN, then you put the VLAN ID. You can configure QoS trust settings with MLS QoS trust costs. This actually applies for the old devices. The MLS config, like legacy 6500. Maybe for the other one, the 3850, I forgot now, those Cisco devices. There's just a lot of QoS options that you can put. Auto detection, use the CDP or Cisco Discovery Protocol or LDP Med for automatic voice VLAN assignment and device detection. To confirm the settings, you need to use the show interface. Then you put the ID, let's say Ethernet 1/1 switch port, or show interface gig 0/1 switch port, and verify the connected devices with show the CDP neighbors. Right. So if you're familiar with Cisco, you know all of these commands that I'm telling you very well. So what is 802.1q tagging? 802.1q adds a 4-byte tag to the Ethernet frame, including the 12-bit VLAN ID, enabling up to 4,096 VLANs. In terms of the tagging process, switches add tags to outgoing frames on trunk ports and remove tags on access ports, facilitating VLAN traffic across the network. So configure 802.1q tagging on trunk interfaces using the switch port trunk encapsulation.1q. 1Q. Switch port, trunk, encapsulation, .1Q. Then followed by the switch port mode trunk. Another concept is link aggregation, also known as port channeling or bonding, and combines the physical links into single logical link. And this technology increases bandwidth, it provides redundancy, and improves network resilience. So the two main protocols are used for link aggregation, which is LACP and PAGP. So LACP is the IEEE standard that allows dynamic negotiation of aggregated links, while PAGP is a Cisco proprietary protocol that provides similar functionality to LACP. Okay. So as you will see here, you have two HP devices. They have a lot of links, let's say 4. So you can actually configure all of them in one port channel. But in this case, there are 2 link aggregation, 1 and 2. Okay, depends on how you use it. This could be an L2 port channel. This could be an L3, because if both are L2 port channel, then because of SDP, one will be blocked, right? Because it's just going to create loop. So if you have this scenario, then maybe one is L2, the other one is a layer 3 port channel. Another concept is speed and duplex settings. The modern switches support various speeds like 10, 100, 1 GB, 10 GB. Now there are devices in the data center which can run to 40 Gbps, or 100 Gbps. So this is for the data center spine and leaf architecture. Auto negotiation is typically the default setting depending on the model, the platform model of the device. Like for Cisco, some has auto negotiation enabled by default, some doesn't. Okay, so you have to consult the documentation. Next is duplex mode. Half duplex allows communications in one direction at a time, while full duplex enables simultaneous bidirectional communication. As a best practice, you have to match the speed and duplex settings on both ends of the link. Use auto negotiation unless specific requirements dictate otherwise. So this means don't always rely on auto negotiation. Just manually configure the speed and duplex settings, because we don't want any half duplex settings running on the network, because this will slow down the traffic. Okay. So how you configure it is simple. Go to the interface, you put duplex full and speed depending on the supported speed of the device or of the interface. Right. So yeah, the other one is speed, and here you have the duplex settings. Okay. So just a reminder, right? Duplex mismatches. So let's say you have a switch here. You have EAT 1/1, 1/1. If this is full and this is half, then that will severely impact the performance. So if you suspect issues related to duplex, you need to check both ends of the link and consider reverting to auto negotiation if manual settings are causing problems. But yeah, as much as we can, ensure we hard code. Let's say this will be full and the other one should be full. Okay. Next topic is about STP. So STP prevents network loops and redundant topologies by selectively blocking redundant paths while maintaining a loop-free logical topology. And this is very important for network stability and preventing broadcast storms. So if you have a switch here, you have another switch. So this is switch 1, switch 2. Pardon my drawing. Sorry, guys. So switch 1 and switch 2, you have 2 links, right? So if you're allowing VLAN 10 here, and you also allow VLAN 10 on the other side, this will cause a loop, right? And that's a problem, because if you have a loop, then that will cause broadcast storms, the CPU will go up, and the traffic, the switches will no longer be able to function properly. So we have STP to police this or manage this, because what STP will do is it will remove the loop logically by blocking one of the interface. So let's say this will be forwarding both interface, but here it will be blocked, right? So the traffic will only go here. It may look like it's inefficient, but this will stop at the loop. So one approach to minimize, let's say you have a 1 gig here, 1 gig, but because of STP, only 1 gig is being used. If there's a requirement to use 2 Gbps in between switches, you can just aggregate it, right? Port channel it. If you port channel it logically from the eyes of STP, it's just going to be one interface on each switch. So there's no way for STP to block any interface because it's bundled as one. Okay. Some key concepts: you have the root bridge, the central point of a spanning tree. You have the bridge ID, and there's a lot more like the root bridge election. You need to understand the port roles, like the root, designated, alternate, backup. Understand the port states like blocking, listening, learning, and forwarding. The STP variants are here, right? The latest ones, best practice, rapid PVST. PVST can also use multiple spanning tree protocol. Okay. So configuring spanning tree is not very complex. Just use this. You need to define the spanning tree, the VLANs that will participate in spanning tree. You need to put the mode, PVST, rapid PVST, or MST. You need to configure the primary, secondary route. So primary spanning tree VLAN, let's say VLAN 10, you put the root primary or the secondary. Then you need to adjust the timers. So yeah, there's a lot of configs available. You can visit the documentation, but please be aware that this is a very important configuration. Otherwise, it will use the default STP, and all of the VLANs will be there, which is bad. So how do you validate it? You show spanning tree interface, show spanning tree VLAN. You can also look for topology changes in the network. Another topic is MTU, maximum transmission unit. So MTU is the largest packet or frame size that can be transmitted over the network. It's typically measured in bytes and varies depending on a network type and configuration. So what happened is that if you have, let's say you have a pipe, right? And this pipe, you can only, how do we describe it, right? If you have a pipe and you have a packet, and this pipe can only allow, let's say, 1500 bytes, okay? So if you have a packet that is 1400 in size, then that will go, go past the pipe or the link without any problems. 1450, that's fine as long as the headers are, if you add the header, right, it's still less than 1500. But if the packet, let's say, is 1700 bytes, right? So depending on the setting of the device, so what's going to happen is that this will allow this packet, but it will fragment it, or it will divide the packet. Let's say it will allow the 1500, but the 200 bytes will be delayed, and it has to be reconstructed at the end of the pipe. So what's the repercussion? So because of that processing, this will increase the CPU of the switches involved in the fragmentation process. So there's a way for us to test it by setting the DF, the do not fragment bit. If you do that, then this is not going to pass. If you send a ping using this size, then the ping will not push through because it's set with do not fragment bit. It's not going to be fragmented. Okay, so this it's one of the best ways to understand if what's the allowed MTU on a specific link. Okay, so What's the impact on performance? Larger MTU sizes can improve network efficiency by reducing overhead, but they must be supported end-to-end. Mismatched MTU sizes can lead to fragmentation and reduced performance. So how to configure it? Verify first using show interface. Go to the interface and you can put MTU. Then what's the bytes like, right? And you can verify using the show interface. Okay, so this is a quick illustration of that. So what happened here is that the MTU size allowed is 1800. You send an empty of 1800, but on the other side it's just 1500, so it means it's going to be dropped. Okay. So jumper frames are Ethernet frames with MTUs larger than the standard 1500, typically up to 9,000 bytes. 9,000 bytes. So typically this is being used in data centers from my experience, right? So all of the interfaces there, you have a spine and leaf architecture. Just set it to, ensure that it's set to allow jumper frames. So it can reduce overhead, improve network efficiency, and better performance for large data transfers, especially in SANs or storage area network and data centers. So all devices in the path must support jumper frames, not suitable for all network types, particularly those with older equipment or stringent latency requirement. It is ideal for high performance computing, backup operations, and large file transfers in enterprise networks and data centers. So how do you configure it? There are two ways you can enable jumper frame system-wide using this command, but this will require a reboot. So just be aware of this for Cisco switches. For configure interface, you can just use interface ID followed by the MTU and the allowed bytes that you want. And you can verify with the show interface, okay? So how do we integrate switching technologies? So unified network design, so integrating VLANs, STP, link aggregation, and MTU settings creates a robust, efficient network infrastructure. VLAN segment traffic. STP ensures loop-free topology. Link aggregation provides bandwidth and redundancy, while optimized MTU enhance performance. Proper integration of these technologies can significantly improve network performance, like for example, using jumper frames over aggregated links within specific VLANs can dramatically increase throughput for data-intensive applications while maintaining segmentation and redundancy. Configuration changes or challenges. Integrating these technologies require careful planning and configuration. You gotta ensure consistent VLAN configurations across trunks, align STP bridges with VLAN arrangements, and configure compatible MTU size across aggregated links and edge devices. Some case studies, data center optimization. We have a large enterprise data center implemented VLANs for traffic segregation using MSTP for redundancy and configured link aggregation with jumper frames for high performance storage access. And this integration resulted in a 40% increase in network throughput and significantly reduced latency for critical applications. Campus network redesign. So a university campus redesigned its network using VLANs to separate student, faculty, and administrative traffic. They used rapid PVSD Plus for fast convergence, and link aggregation was used between buildings. The result was improved, better resource allocation, and enhanced network reliability. Third case study, a manufacturing facility integrated IoT devices into its network using VLANs to isolate industrial control systems. STP was crucial in providing redundant paths, while QoS settings ensured priority for the critical control traffic. This integration improved plant efficiency and the network uptime. Right? That's the end of the lesson. Here we spoke about switching technologies, and we talked about VLANs, interface configuration, spanning tree and its configuration, MTU, and some case studies about the switching technologies. Okay? I hope you enjoyed the lesson. Thank you very much for watching the video.